So this comes from our review, which is question 3L, and we're simplifying this equation. So the first thing that we're doing with this question, so we have 2x squared y over 5 minus 3y x squared over 4 plus x squared y over 2 minus y squared x over 4. So the thing that we first are going to look at before we even consider getting rid of fractions or anything like that is where are our like bases? And so our like bases, when we look at it, it doesn't matter the order of which the letter is represented. So we're going to start with just focusing on the x squared y. So for all the other terms, we're going to look to see if the other terms have an x squared y in it. So our second term is yx squared, so that's also 1. It has the x squared in it as well as the y. So it doesn't matter that the y has come first because it's multiplication through. So it's really saying 3 multiplied by y multiplied by x multiplied by x. And that again is what our first term is saying, 2 multiplied by y multiplied by x multiplied by x. It's just rearranged differently. So those are like terms. And we look to our third term, and yep, this one is also a like base because we have the x squared and we also have the y. When we look at the fourth term, we have a y squared this time. So this one is actually not a like term. So what we can do is combine these ones here. And so this is basically going to become, because it's a simplification problem, which means we're simplifying the algebraic expression. And so what that means is we're not actually solving for it because we don't have an equal sign anywhere. So we're just going to combine like terms, and it is the same approach as we were adding and subtracting fractions. So in our denominators we have a 5, we have a 4, and we have a 2. So we need to find a common factor between those. So the common factor we actually will use is 20. And that's because all of our denominators goes into 20 equally. So just like with fractions, what we're going to do is we will make every denominator be 20. And what we do to the bottom, we must do the same to the top. So what we have here is we had 5, we made it 20. So what we've done is we've multiplied 5 by 4. So what we do to the bottom, we must do to the top. So because we have a 2, we will multiply that 2 by 4 as well. So we get a 8x squared y. Now we've got a 4 in our second term here, so we're multiplying that this time by 5 to get that denominator of 20. So again, we'll multiply our numerator by 5 as well to give us 15, and we still have that yx squared. Our third term is our denominator is 2, so we're going to multiply that by 10 to get that 20 as our denominator. And so we're going to multiply our numerator as well. So again, when you have no number in a numerator or just dealing with algebra, it's assumed that it's 1. Okay, we just don't write that because it's assumed. So it's actually going to become 10x squared y. And we'll just drop down our fourth term here, even though we're not doing anything with that term. So what we're going to have now is we're going to combine, it's just adding and subtracting all of our numerators together to get our like terms. So we have an 8 minus 15, so that gives us a negative 7, and then we have negative 7 and we're adding a positive 10 to that, so that will actually give us a positive 3 in our numerator. And because all of the variables are the same, in each of these three terms we have an x squared y, and that's why we're able to combine them. That's why we're just keeping the same terms down, those letters. And so everything will still have that same denominator because it's just a question of adding and subtracting fractions. And then we'll just bring down that last term, so minus y squared x over 4, and that becomes our final answer. And so again, it's a simplification because we started with 4 terms at our top of our expression, and now we've moved it down just to 2. So this would be easier to solve if we had values for x and y.